So here's the solutions to quiz number 1. There are 3 problems. Let's look at problem 1. It says find compound amount and compound interest of an investment of 4,000 US dollar. So that's the P, or the principal, at the end of 5 years and 6 months. So the period is 5 years and a half with the rate of 5%, right? Remember, this is annual rate or annual percentage rate, or APR. Compounded quarterly, right? Okay, round your answer to decimal places. Okay, so first the principal P is 4,000. Now it's important that you have to determine the period. So one period is 1 quarter. Okay, so interest, we have to find interest per period. Remember, 5% is per year. 1 year has 4 quarters, so interest rate per quarter has to be smaller. So it's 5% divided by 4, right? So interest rate per period, or in this case it's per quarter. It's 1.25%, or 0.0125. N is the number of period. So in this example, we are looking for the number of quarters. Okay, so 5.5 years, right? So 5 years corresponding to 20 quarters, and then 6 months, it's another 2 quarters. So N is equal to 22. Now the formula, the compound amount is equal to P multiply bracket 1 plus R to the power of N. Okay, so P is 4,000. 1 plus the interest is 1.0125, and you raise it to power 22. You compute this, you get this compound amount, right? Which you have to round it into 2 decimal places. So compound amount is $5,257.15. Compound interest, you subtract that amount from the principal, you get $1,257.15. Okay, so this problem worth 4 points. Next one, they give you the values of log of x base a. So you notice that the base is a. Log of y base a, right, is equal to 1.8, and log of z base a is equal to 2.5. Now the access to find log of this thing. So we apply the properties, right? So log of a product become the sum of the 2 log, right? So it's become log x plus log z divided by y, right? So it's minus log of y. All of these are base a, right? Because the problem indicate that the base is a, right? So you can use the values given, right? Log of x base a is 1.5, log of z or z base a is 2.5, and minus log of y, right? And finally, the answer is 2.2. This is worth 2 points. Okay. Next one, the access to find this quantity, right? And you notice that the base is not a, but it's the x. Okay. So first we deal with power 3. Again, you use the property, the power become multiplier. So 3 multiplied with log of z base x. Now we're gonna change this from base x to base a. So you got log of z base a divided by log of x base a, and both of this is given in the problem. So 3 multiplied with 2.5 divided by 1.5. So the answer is equal to 5. Okay. Okay. So this is worth another 2 points. Let's go on to the last problem. So the last problem, it said a donor wishes to start endowment. The endowment will provide scholarship of $400 per year forever, but we're gonna start next year, not now. University earn 10% per year on the endowment, right? So this is interest per year, which is 0.1, right? 10% is 0.1. Okay, so let's think about this, right? In terms of the first year, remember the future value is equal to present value multiplied with 1 plus r to the power of n. Our period is 1, right? It's a year, right? We are looking at the first year, so n is equal to 1. Interest rate is already per year, right? So 10% of 0.1. Now future value a year from now, we want to keep out $400. The question is, what is the present value now? Okay, so you can solve for PV or present value. So it's equal to 400 multiplied with 1.1 to the power negative 1. Okay, so that's for year number 1. Year number 2, we can do the same kind of equation, but now the power here become 2 because it's going to take 2 years. And again, you solve for PV, so it's 400 multiplied with 1.1 raised to power negative 2. 3 years, it's going to be power negative 3. 4 years, power negative 4. And we compute using calculator to compute the present value. And you see that it's definitely going to be less than 400. Right? So $400 in the future, what is worth now, it has to be less than 400. Okay? And you see that if the years, it's a longer period, the values of that $400, it's going to be much less. Okay? Now it say, okay, how much is the lump sum must be donated now that for the endowment? Okay, so we want to find the sum of everything in the third column here, but it's gonna go on forever. Okay, so first term is this, second term, third term, and this keep going indefinitely, right? So this is the sum, infinite sum, and you see that the first term, that's the a, so a is 400 multiplied with 1.1 to the power negative 1. The r, right, this is geometric sequence, the r is 1.1 raised to power negative 1, right? So you keep multiplying that term to go on to the next term. Okay, so you use the formula, right? A divided by 1 minus r, and you see that the r, which is 1 over 1.1, this is definitely less than 1, so you can use this formula. Okay, so you plug in everything, right? So a is 400 multiplied with 1.1 to the power negative 1. 1 minus r. Okay, compute this, you get 4,000. So you need 4,000 US dollar now, right? To be able to pay out $400 per year, right? Starting next year forever. Okay, so this is gonna be worth another 2 points. The first part, that's 2 points. So 4 points total. And at the end, if you add everything, you get 12 points.